Well, on the contrary, Kepa, thanks a lot to you for the invitation, for the kind words. It's always a pleasure to be here. Before I begin, I even feel I should apologize because I am not a super external speaker, actually. Although I come from Madrid, I spent most of my life in Bilbao, so I am more like your neighbor coming from from a university just an hour away from here. Yeah, also, I should warn you that during this talk, you will be experiencing subliminal primes that will influence your mind, behavior, feelings even. So if you find yourself doing something unexpected, saying out athletic or wanting to move to a different town, maybe that's a secondary effect of this talk. Well, okay. So once again, thanks for the invitation. Well, if you ask a physicist what's the deepest question in research about the universe right now, maybe some of them, at least the most philosophically oriented of them, might reply with something like this. Why is there something instead of nothing? So even before we start studying particles, energy, why do we have these particles to begin with? And I feel that that's also the deepest question in psychology as well. We study language, memory, learning, and so on. But ultimately, the question is why all these things come with this subjective experience? Why do we need to experience all these things for our cognition to work? Or in other words, why is there something it is like to be you or to be me? ChatGPT can do lots of interesting things. In a way, you could say it is intelligent, but there is probably nothing it is like to be ChatGPT. So in what ways our experience contributes to cognition? Do we need it, or could we just be robots or zombies and things would work just the same? So there are different ways in which you can approach this question. Some researchers try to explore the structure of consciousness. The first striking characteristic of experience is that it is not chaotic, that there is some regularity. So that's one thread of research. A second one would be, well, what's the use of this? Is there something we can do because we are conscious? And finally, this is more a question for you guys. What's the neural substrate of consciousness? How the brain produces this subjective experience? Well, if you are expecting me to give you answers to this question, you can go back home. Unfortunately, I do not have the answers. And I think to some extent, nobody can. We have lots of theories about consciousness, all of them very interesting. We have thousands of experiments. It's a very exciting area of research, but it is not making progress very fast, I would say, compared to other areas of research. And probably part of that is that, well, the topic is just too complicated. We have been speculating about the characteristics of consciousness from a philosophical point of view for centuries. So we should not expect to find a solution to this in just 10 years of empirical research and brain scanning and so on. So it's going to take a time for sure. And maybe that explains 90% of why our progress is so slow. But my talk is going to focus on the remaining 10% that explains why it is so difficult to make progress. And part of the answer that I will give to this is that the methods that we use are not always optimal. Sometimes in unconscious learning and memory research, we fall in very basic methodological errors that undermine progress in this particular area of research. Probably this does not apply to all unconscious cognition, but it certainly does apply to very specific areas like implicit learning, which is my main area of expertise. And most of the examples that I will be showing you come from this particular area. What's the expert consensus on unconscious cognition? Well, a recent survey published, I think, a couple of years ago, asked many researchers whether they thought that different cognitive processes could take place unconsciously. When I saw this figure for the first time, I found it a bit shocking to begin with because there is a lot of green in that figure. Green means that researchers tend to think that those cognitive processes can take place unconsciously. So if you agree with this figure, it is not completely clear what consciousness is for. If you can even have things like metacognition or thinking or even arithmetic performance explained by unconscious processing. So what's the contribution of consciousness if you agree with this? So there is a lot of green here. That's the first shocking result. The other one is that even though there is a lot of green, it is not the brightest green. It is the shaded green and shaded red and gray in general. So the other interesting thing is that researchers are not very confident about the response in one direction or another. So basically, they are confessing, yes, we don't really know whether all these things depend on consciousness or not. What I will try to convince you over the course of the talk is that there is too much green here, and that probably one of the reasons why there is so much green, well, it could be evidence, of course, that there is evidence behind these claims, but there is also a bit of fashion and sometimes a bit of bias as well, okay? There are different methodological problems that maybe bias the opinion of the community towards believing that many things can happen unconsciously. Part of the reason for believing this lies in a study that I published many years ago. It seems like another life. Actually, here, this was a systematic review of a very specific implicit learning paradigm. And at some point, we decided to check what were the journals where all these papers were published. And it turned out that the impact factor of the journals where people published things claiming that the effects were unconscious were systematically higher. So if you wanted to publish your paper in the highest ranking journals, your chances were much better if you could somehow argue that the effect was unconscious or implicit or automatic. In the title, that was the predictor in our analysis. If the title mentions this is automatic, this is implicit, unconscious, then it is published in a higher impact factor journal. So there could be a bit of fashion and bias behind this emphasis in unconscious processing. This doesn't apply to all the experiments that I will be mentioning here, but a very common strategy to claim that cognitive process can be unconscious is to find a dissociation like this one. You find an effect, a significant effect in some measure of performance. This could be an effect measuring learning, memory, semantic processing. It could be mask priming. So there is a condition where you find a significant difference in performance. And then at the same time, you have some measure of awareness, trying to see, for instance, whether participants can discriminate the stimuli you have been presented. Maybe they have been presented subliminally, like the athletic symbol. Or maybe it's not that the stimuli are subliminal, but it is just that there is a hidden regularity and you want to assess whether participants notice that regularity. So this is the ideal pattern of resort to convince the audience that the effect is unconscious. You find a significant effect in performance, but you find non-significant evidence of awareness. And what I like about this particular predicted pattern of results is that there are two ways in which they can be wrong. On the one hand, maybe that significant effect in performance is a false positive. There is always some risk of a type 1 error, which is never just 5%. It is way higher than 5% and very often impossible to estimate. But what is interesting about this pattern of results is that the absence of awareness could also be a false negative. And this is interesting because if you have been reading about the replication crisis, the crisis of confidence in psychology and other disciplines, most of those studies are focused on false positives. But there are many areas where what you have to worry about is the false negatives. Even in medicine, it is not only that if you have evidence that one medicine works, well, that could be a false positive, but you could also have a false negative for the claim that it is safe, that it doesn't have any complication and so on. So false negatives are just as relevant as false positive. Is everything fine?
Someone was telling in the chat that there is an echo.
Maybe it's the other microphone.
Can you turn it on now?
Is it okay now? Maybe they are typing something in the chat.
Yeah, it's okay now. It was, I think, a mic on the extra laptop.
So it's better now.
Okay, perfect. Great. Done. Okay.
Okay, excellent. No, don't worry, it's fine. So false negatives in this area could be just as harming as false positives, but they have not received so much attention. Do we have any reason to suspect that some results in implicit learning at least are false negatives? I think so, and much of the evidence comes from a particular experimental paradigm that we have been using a lot. It's a visual statistical learning paradigm known as contextual cueing. Maybe you are already familiar with it. So what participants have to do in these kind of tasks is to find a letter T surrounded by L-shaped distractors. So in that case, you can see in the upper corner, the T, participants have to find the T and report the orientation. So what we measure is the reaction time, the time taken to report the orientation with the keyboard. There are hundreds of trials, sometimes even thousands of trials. Occasionally, we keep participants for a couple of hours in the laboratory. So yeah, it's a bit perverse, maybe. The experimental manipulation is that many of these search displays are completely random arrangements of T's, L's in different colors. But occasionally, there are some displays that are presented repeatedly over the experiment. In most of the experiments, there are 12 patterns that are presented once per block. So by the end of the experiment, participants have seen them many times. And as you can probably guess, the typical result looks something like this. Over the course of the task, participants improve in general, of course, or the reaction times decline, but the decline is steeper for the patterns that have been repeated. So clearly, participants are not just learning something about the task, they are learning something very specific about those displays. You could think of this as a laboratory analog of Finding Waldo and all these books, which are also books that you can only play once because we are so good at detecting this regularity. So in a way, we are trying to capture that ability, that very good ability to learn from experience to find things. Well, the interesting thing for today's talk about this phenomenon is that it is very often claimed to be unconscious. And the reason for that is that often at the end of the experiment, we reveal participants the manipulation and we tell them, well, maybe you noticed this, maybe you didn't notice, but there are a few displays that you have seen 20 times over the course of the experiment. So now we would like to know if you can recognize those displays. So we present them again with those displays, but this time intermixed with, again, completely random patterns. In our experiments, they have to say whether they remember seeing that display or not, and also using a confidence scale, which is very useful also for computing measures of metacognition that I will not be talking about today. Also, the typical result is that participants apparently cannot do this very well. Oh, no, Jesus Christ, I have never seen this before, and so on. So, okay, in principle, they tend to do this at chance level. There is non-significant evidence of awareness, recognition, however you want to call this. So is there any reason to suspect that this could be a false negative? I think there are good reasons. This is what we call in meta-analysis a funnel plot. It is like the expected distribution of effect sizes that you would expect given a model. In this case, the model is that participants are not aware. This is a funnel anchored at 0. So this is what you would expect, where you would expect to see the effect sizes if participants actually cannot do this very well. But this is actually where you do find the effect sizes. So as you can see, it is a bit displaced towards the right. This is the panel that fits the data best. And so participants seem to be able to release above chance. Maybe you cannot detect that in a single experiment with just 10 participants, but meta-analytically, there is clearly some above chance recognition in these experiments. If you prefer to see a section of this is maybe more familiar to you, the typical representation of the null hypothesis and the alternative hypothesis. The only reason why these results tend to be non-significant is just a lack of statistical power. The statistical power of this test is 21%. And this is a cosmic coincidence, but exactly in this data set, you see 21% of significant results. So this is a case where the prediction and the observed result is exactly the same. So it is not that participants are unconscious. We simply have an underpowered test. And so maybe at this point, you are a bit puzzled by this because all these experiments in a way are very well powered. They detect contextual cueing very reliably. So how can they not be well powered for something else? Well, there is a very simple explanation for this. Even in the seminal experiment exploring this is what the visual search task looked like. Participants had to complete 30 blocks of 24 trials. That's over 700 trials. That's how you measure whether learning has taken place. And now when it comes to awareness, you only include a very brief awareness test with only 24 trials, I think. So of course, if you have a lot of sensitivity to detect learning and you don't have so much sensitivity to detect awareness, you are doomed to conclude that you are finding evidence of unconscious learning, but this is entirely a statistical artifact. This is not actually evidence or substantial evidence of unconscious learning of any kind. Sometimes it gets much worse than this because There are visual statistical learning paradigms where awareness is measured with a single question at the end of the experiment. So you have, again, 800 trials to measure learning. And at the end of the experiment, you have a question like, did you detect something? And if participants say no, then that counts as unconscious learning. So this is pretty common in other visual statistical learning paradigms related to contextual cueing. Okay, so clearly there is an asymmetry in statistical power. So my first, by the way, if you bother to collect these measures of awareness with a sufficient number of trials, using meaningful questions that participants can understand and so on, you systematically find evidence of awareness in all of these statistical learning paradigms, at least in the visual domain. So actually the evidence for unconscious visual statistical learning is very poor. There are just a handful of studies where you can say, well, this is convincing enough, okay? In most of the cases you can find one or several of these methodological problems. I suppose that visual statistical learning is not the most important topic for most of you, but many of you must be familiar with masked priming, lexical decision. I suppose that many of you use this kind of tasks. Maybe you remember David Hernandez Gutierrez, who was a colleague until I think a couple of months ago. So this is one meta-analysis that he conducted while he was working with us in Madrid a couple of years ago. And in this case, what he was trying to explore was a syntactic priming experiment. So it's a typical subliminal priming experiment, only that here the relationship between the subliminal prime and the target was syntactic. So if they belonged to the same syntactic category, they were both verbs, then participants were faster at detecting the target than compared to if they were from different syntactic categories. As in the case of statistical learning, the authors, the main authors of this paper were Stanislas Dehaene and some of his students, and they claimed that this was unconscious as well, because if they asked participants to discriminate the prime in a separate test, again, participants didn't seem to be able to do this above chance. So what David did here is just what I did for contextual cueing, to conduct a meta-analysis, and he found exactly the same, that you do find clear evidence of visibility if you bother to have sufficient number of the data, if not with trials, at least with participants collating data from many studies. You might complain, I will go back to that maybe, well, this is above chance, but this D prime is only 0.01. So if you are familiar with signal detection theory, well, participants are detecting something, but it is not like seeing anything very clearly. So you might still argue, well, that still counts as unconscious learning. They are seeing something, but not much, and still you have a strong priming effect. So I will get back to that, okay? But basically, this is not as small as it looks. It is more or less what you would expect. But in any case, I am going to release my conclusions little by little. So my first conclusion for you would be careful with statistical power, not only in the sense that your experiment should be well powered, but also keep in mind that when you report your results, very often you include many different statistical contrasts, and you cannot assume that because you have good power for one of those analyses, you also have very good power for the remaining analysis. And because you have different levels of power for different analyses, occasionally you will see patterns that look like dissociations, and you will see something appearing here that doesn't appear in this other place. You might build a very sophisticated story to explain that dissociation, but in the end, it could just be noise driven by different amounts of statistical power in different measures or in different analyses and so on, okay? So always be careful with statistical power. Going back to this study by David, is that effect too small to account for masked priming? Well, that's a bit an unfair comparison. When you are studying priming, again, you collect data over hundreds of trials, and you collect reaction times, which are a continuous dependent variable. It is more sensitive. So it might look like priming is a very strong effect. But what would happen to that priming effect if somehow you were able to translate it to a D prime score? Let's imagine that you could convert your dependent variable and compute something comparable to this. Well, it turns out that you can do that kind of things, that you can extend signal detection theory for reaction times. And the answer to that is that when you measure priming in D prime scores, you get exactly the same size as web awareness. So yes, this is small.
But the syntactic priming effect is also very small. It only looks large once again because you have 900 trials and because reaction times are a bit more sensitive than yes, no responses. But that's okay. So we have done this for contextual cueing. In the case of visual statistical learning, we have compared awareness and learning using the same metric. And here in this graph, I'm not going to explain it in detail, but basically every black dot is a measure of awareness, and the white dots are the corresponding measures of learning in reaction times, but converted to the same dependent variable. And as you can see, there is no systematic advantage for one of those colors over the others. In general, the amount of awareness that you see, however small it looks, is just what you would expect to find based on how large the learning effect is. And you can find the exact same pattern in many other areas of unconscious cognition. So in this paper, they explored examples of unconscious semantic priming, unconscious numerical cognition, lots of different paradigms. And again, the trend was the same. Once you make the comparison fair, there is no longer an advantage for the behavioral effect over the measure of awareness. Okay, so in general, another conclusion here is that all these effects tend to be quite small. Just because we find them reliably in the laboratory with optimal parameters doesn't mean that they get explaining a lot of variance, okay? They are actually very small effects, and it is normal that participants do not show very good awareness. Well, that's just what you would expect given a small effect. Okay, there is another way to approach the question of whether this is too small to matter, which is to use modeling. Let's imagine that contrary to what Stanislas Dehaene claims, this is completely conscious. What you see in the priming measure is exactly the same as what you see in the awareness measure. What would you expect to find in your dependent measures? Well, what you need is a computational model that tries to link both concepts and see what is the D prime that you would expect based on that. So we have not done that for syntactic priming, but we have that kind of analysis for visual statistical learning measures. So what we do in these models is simply to have different equations to explain learning in reaction times and also performance in the awareness test, but we make an effort to have the same parameters driving performance in both dependent variables. So this would be equivalent to saying that whatever participants have learned and this driving performance in the reaction times is also what is driving performance in the awareness test. So from this model point of view, there is no unconscious learning at all. What you see in both dependent variables is measuring the exact same thing. And when you do this, you very often can come across with models that explain very well both the reaction times and the patterns of results in the awareness test. So what you see in the awareness test might look very small, but if you actually have a model, that's what you predict on the hypothesis that this is completely conscious, okay? So my second temporary conclusion would be something like this. If you are claiming to have found something, it is often very useful to know what would you expect on the opposite assumption, which we almost never do, and is very important in the case of unconscious cognition. If you want to claim that you have found an asymmetry, the first thing you have to do is to test, well, what would a reasonable model predict, assuming that there is no asymmetry and there is no dissociation. And modeling can be extremely useful for this. And in combination with modeling, also alternative approaches to statistics, like for instance, Bayesian approaches. If you have a Bayesian model, it is very easy to try to assess the fit of your model to this kind, to what participants are doing in those experiments. Well, occasionally, the claim that learning is unconscious is based on a slightly different logic, but it is equally problematic. For instance, in the case of contextual cueing, yes.
One question, Miguel. Questions at the end? Or?
No, it is fine if you want to interrupt me.
Okay, I have a question in relation to this second conclusion that you were reaching. I wonder to what extent there are, I don't know much about unconsciousness, but to what extent there are designs that are parametric in the sense that, hey, it's unconscious until a certain level and then becomes conscious. Is people doing that across different cognitive dimensions or not? It's not a practice at all.
So for instance, claiming, well, if you have here 0.1, that is compatible with consciousness. If you have 0.05, then it counts as evidence for unconscious or not.
No, I mean, for example, in the case of working memory, right? Which is basically keep in mind some items, one item or two items. Is people doing parametric designs in the sense that, hey, yeah, if it's 2, can be unconscious, but if it's 4, it cannot be, because those kind of parametric designs can be very relevant, at least in the quantitative dimension,
Yes.
because there can be qualitative jumps between different states, right? But I was wondering to what extent people have in the field parameterizes this in order to see there is something related to the incremental.
Not as far as I know, in the specific case of visual statistical learning, that in this particular setting, the evidence is more convincing. I think that in other areas, for instance, unconscious working memory, this might be the case. I think trying to find for the specific combination of parameters, maybe not necessarily in the sense of running a parametrical study with different values, but trying to find the optimal parameter values through a staircase or something like that. So in other areas, I think that maybe that's more common, especially when you are presenting subliminal stimuli, finding the optimal contrast and size of the stimuli, that can be a bit more common. But this is definitely not done in visual statistical learning at all. So yeah, there are probably differences across areas. Of course, it is also more difficult in the case of visual statistical learning to think what could be the parameter that can be manipulated so that you can get the ideal level of awareness that you would want 0, but you still see an effect in performance. Is it the number of items in the screen? Is it the difficulty of the task? You can make the else. So you could potentially do things like that, but not guided by a very specific hypothesis. That's a bit like going blindsided, touching all the keys just to see if you find something. But no, not as far as I know, or I cannot think of any convincing example right now. With subliminal stimuli, yes, you find that. Yes,
Thank you.
yes. Okay, very good question. So another approach to claim that an effect is unconscious is to explore correlations between performance and awareness. In the case of contextual cueing, let's imagine that you think that contextual cueing is perfectly conscious. Then you would expect that participants who show better evidence of awareness should also be the ones showing a stronger contextual cueing effect. So it makes sense to test for a correlation. If you find a correlation, okay, maybe this is conscious. And if you don't find a correlation, you could take that as evidence that performance is independent for awareness, and therefore it is unconscious in a way as well. Okay, so this has been done very frequently. And even in my own experiments, I don't find any correlation between awareness and performance. So you could take my own data to claim that contextual cueing is unconscious, but don't go so fast. There are many other papers showing very small correlations with lots of noise, nothing systematic. And this paper is particularly remarkable because here they find correlations very close to 0. But in one of those experiments, I think it is in the third one, they had 700 participants. So clearly you cannot attribute any null result here to lack of statistical power. They tortured lots of people to get this result. So is there any chance that there is something else happening here? Maybe there is some other artifact that we are dealing with, which is not a statistical power, something else that could be diluting the correlations and obscuring correlations that maybe are there, but we cannot see for one reason or another. And I think so. I think that there are good reasons to explain 0 correlations virtually here, even if you believe that contextual cueing is perfectly conscious. If you think about the experimental tasks that we use in general in the laboratory, this applies to my task and probably to many of the tasks that you are using. One of the features they have is that they have very low internal consistency. This means, for instance, that if you test the same participant on the same task this morning and this afternoon, you might not always find a correlation between what they are doing at both times. Or if you have an experiment with 1,000 trials and then you split those trials into equivalent sets, you might not find a correlation between what you get in both sets. And this happens in, I would say, 90% of the tasks that we used in experimental psychology, not in all of them, fortunately, and things can be done to fix this. But for instance, a recent paper exploring this in many popular tasks like the flanker task, the Stroop task, the typical Posner-like effects. What you see in this scatter plot is the correlation between the results taking one half of the experiment compared to the results of the other half of the experiment. And what you can see is that many of these tasks do not correlate with themselves at all. You would not even appreciate any correlation there. So the question if these tasks do not correlate with themselves, how can they possibly correlate with something else, including awareness? That doesn't mean that these or other effects are unconscious. It just means that you have lots and lots of noise And whatever the correlation at the latent level, you will never see that at the empirical level with such noisy measures. Do we have any reason to think that this does not apply to visual statistical learning? No, it is exactly the same. In one of our papers, we estimated the reliability of contextual cueing. It is often between 0.4 and 0.5. That means that 1/2 of the variance, at least that you see in the data, are just noise. So that half cannot correlate with anything. You just have the other half to detect correlations, which is not a lot. When you work with questionnaires and surveys, you are often expected to get reliabilities in the order of 0.8 or even 0.9. So compared to those psychometric standards, this is just noise. There is no reason to expect any correlation here. And it is even worse for the measures of awareness. Recall that the typical measures of awareness include only 20 trials. So of course, that's entirely driven by noise. In some cases, reliability is just 0.1. So 90% of the variance is noise. How can that possibly correlate with anything else? And there are reasons to suspect that the state of affairs is even worse in other laboratories. I don't want to presume that we are doing things better in my laboratory, but it is true that we use many more trials than is common in these literatures. For example, in our awareness test, we often have more than 30, 60 trials and so on. So what you see here is the projected reliability for experiments with a typical number of trials. So the reliabilities that I get, that sometimes get close to 0.5, are probably not representative to what you could get with a smaller number of trials. It is very easy to make predictions of reliabilities with different trials based on classic test theory, okay? So there is probably a very large problem with reliabilities. I have even tried to torture the data to see how reliable they can become if I do all types of possible analysis you can think of. For instance, working on reaction times, you know that there are probably 1,000 ways of filtering reaction times. You can log convert them, you can remove wrong responses, remove outliers, not remove outliers. There are hundreds of rules you can use to filter reaction time. So I tried to do everything I could to see if any combination of analysis would result in a better reliability. And the answer is that it is almost impossible to get reliabilities above 0.5 in contextual cueing. It doesn't matter what you do. So there seems to be a very narrow ceiling for the improvement of reliability. I'm not measuring my time. I'm still fine, right? Oh, okay, well, so maybe I was slower than I thought. Okay, it gets even worse if you are working with children, which I think some of you are doing, right? When you see the children pressing the 2 keys, of course, that's only noise. In the case of contextual cueing, I even got reliabilities slightly negative. So this is the kind of data you probably have when you are working with children. It's very difficult to get any correlation between that and something else. I'm afraid this applies to syntactic priming and probably semantic priming as well. In the case of priming, we even found systematically negative reliabilities, which do not make sense from a statistical point of view. The only way you can get negative reliabilities is if it is so bad and you are so unlucky that by chance it gets negative. Okay, so this is how bad it is. There is no chance you will find correlation between that and any personality character. There are many studies exploring whether contextual cueing is different for older participants, for younger children, for dyslexics, for children with conditions. Systematically, the answer is no. There are no differences. But how could you detect differences when you have this kind of reliabilities? Okay, it is only natural. And of course, if you want to explore whether there is a domain general skill you would call statistical learning, well, your chances of detecting that are bounded by such low reliability. So there is much room for improvement here. So my third recommendation for you would be, depending on the type of research you are doing, be careful with the psychometric properties of your measure. We never do this as experimental psychologists because only psychometricians care about this kind of things, but we should care about them depending on the type of analysis we are doing. And well, so far I have only been talking about false negatives. I don't have very strong reasons to suspect that we have many false positives in many areas of unconscious cognition, like statistical learning. But in some areas, there are good reasons to suspect that we should not trust the findings to begin with, not just the claim that they are unconscious, but the reliability of the finding itself. You might be familiar with one of several of these books, particularly Daniel Kahneman's Think is Fast and Slow. You remember probably that that's where the general public was presented with the idea of system 1 versus system 2. What you might not know is that almost half of Daniel Kahneman's book, the evidence on which it is based, is completely irreproducible by independent researchers. So, for instance, very large chapters of this book are reported to what some people call social priming paradigms, where you are exposed to subtle stimuli in the environment, and that changes completely your behavior. Imagine there is a crucifix there, and so I behave different just because there is something I am barely noticing. The classic study here is this one by John Batch. You must have heard about this one. This is the experiment where participants had to do some verbal tasks managing words related to the elderly, like old, gray, Florida, retirement, and so on. And after doing that, what researchers did is to measure the amount of time it took participants to get to the elevator outside the laboratory. And the very famous result is that people who were exposed to the words related to the elderly took longer to get, so they were behaving like older people. They were all students. They took longer just because they had been primed incidentally with all these words. What's the problem? And this has been very thought-provoking. It appeared in all classic textbooks on psychology until recently. And then suddenly, about 10 years ago, people started to care about replicating this, and nobody could replicate this, at least not in a pre-registered study, okay? So this seemed very elusive. And the same happened with other very famous social priming experiments, like being exposed to money or whatever. Do we have more reasons apart from the failed replications that this could be false positives? Yes, we have meta-analytic evidence as well. I'm going to mention just a couple of examples. This was a review on something called money priming. This is the idea that being exposed to money makes you more selfish, more conservative, and so on, a bunch of different characteristics. And in this review, they offer citations to many relevant papers. So what I did is to check the distribution of the effect sizes of those studies. Once again, this panel represents the distribution of effects you should expect to find. And when you plot the effect sizes here, what you see is this, which, well, more or less fits inside the funnel, but it doesn't look like a triangle at all, right? It's more like a straight line. And in particular, there is a lot of cluttering in that area. Is there something special over here that explains why you have all those effect sizes there? Yes, there is something very important there. This is how the data would look like if the null hypothesis were true. So everything falling in the gray triangle is non-significant. And so what you can see now is that all these points are escaping from non-significance. So either there are lots of studies conducted in this area and we are not seeing them because they are not considered publishable. That's one possibility. Or maybe there were points originally here and they have been reanalyzed in different ways until by chance they jumped to the correct side of significance, okay? And you find this pattern in many social priming experiments. You don't see this very often in the kind of experimental psychology that most of us practice, which is very good. But in social psychology, unfortunately, you find lots of this. This is another example from something you could call romantic priming, seeing pictures of attractive women drive men crazy. Similar things with women. Okay, so this is the distribution that you see in the literature. So again, there are good reasons for suspecting that these are just false positives, biased by selective publication, questionable research practices. You are well familiar with how different ways in which you could achieve this. Well, I'm saying that this probably doesn't happen in many laboratory experiments, but this is not completely correct because at least in one statistical learning paradigm, we have found a similar panel. So we could also have some problem of selective publication, maybe not as severe and as in social psychology, but there might still be something going on. You don't have to feel guilty about this as psychologists because there are explorations of publication bias across different scientific fields, and we are not worse or much better than the rest of disciplines. Actually, in this study, the area that seemed to have the strongest problems of reproducibility was economics. And surprisingly, medicine was doing quite well. Maybe because in medicine, it is very common to pre-register your hypothesis, otherwise you cannot publish, and so on. So psychology is just in the middle of these two two extremes. And of course, we have evidence of bias in cognitive neuroscience, so you should worry a bit about this. In the particular case of research on bilingualism, there is very strong and clear evidence of bias as well. We can talk about that later. So my final advice for you, well, be critical with what you read. You cannot believe, unfortunately, everything you read, but try at least to reduce bias in your own research so that other people can trust your findings at least. And you know there are different measures you can take to make your research reliable. Pre-registration is easy, straightforward. There is a new publishing format called register reports. I don't know how familiar you are with this, but this is something worth discussing. Basically, in this publishing format, you submit your manuscript to the journal before collecting the data. So the journal commits to publishing your study before you actually run the study. So there is no way they can impose a publication bias because the decision of whether to publish or not is independent from the results, it's previous to the results. So there are different things, and maybe we have to change other things in the way we practice science and relax a bit, be a bit slower at publishing and so on, right? So to conclude, yes, there is little we know about consciousness. Part of the problem is that all methods can be improved, but we are quick learners and we are doing fine, and all these problems have solutions, fortunately. And that's all. Thank you, Miguel.